We're live. Hello, everyone. Good to see you. Today we have a really fun show for you. We're going to talk to a couple developers from a recent hackathon of ours, and they're going to share some insights into the RB3 Gen 2 and their experience building on the platform. All of the teams are from MIT, so it was, as you'd expect, they put together some pretty cool applications, and so excited to share them with you. So before we get started, we'll do some quick intros. I'm sure you guys are familiar with some of us. I see Rajan just got called out in the comments, so that's awesome. I'm Nick. I'm the developer advocate at Qualcomm. I work with AI compute. I've been in a bunch of these. If this is not your first time, welcome back. Thanks for joining us again. And if it is your first time, welcome. We have a lot of fun. If you have any questions or things you want to say, drop it in the chat on either YouTube or Discord, wherever you're watching the stream, and we'll pick those up. So Rajan, Ramya, why don't you guys introduce yourselves and then we'll get started.
Yeah, sure. I can go first. Hey everyone, I'm Rajan. I've joined one of these sessions before with Nick. I love to do these more and more. I'm part of the developer marketing team within Qualcomm. Anything developer facing, anything anybody needs to build on top of Qualcomm platform. I'm a tech evangelist. Work with all the different teams within Qualcomm and the developer team and Nick very closely to help developers build applications on top of Qualcomm platforms, right? So today, really excited to share all of these good work that all of these teams did at MIT. Looking forward to this session.
I can go next. Hello, everyone. This is the first time that I'm joining the Discord session. So, hi. My name is Ramya. I'm an engineer from the same developer marketing team as Rajan. Developer advocacy and developer enablement are a really big part of the work I do here at Qualcomm. And throughout the year, we go to many different events, and MIT is really one of them. And I've been there just once. I missed this year, but I was there last year, and it was super interesting to see all the crowd doing really fun stuff with the glasses, with the IoT kits and stuff. And today we are like really excited to talk to some of the winning teams and have them present their work. So really looking forward.
Yeah. So, and that's a perfect segue. We'll do a quick intro with the teams. So we can bring them on stage quickly. What we're going to do, we'll do an intro with all the teams. Then we'll have a short presentation from Rajan about the hackathon. And then we'll go back to each team individually where they can talk about what they're building or what they did build, excuse me. So why don't we start with Mayank? Go for it.
Yeah. Thank you so much for inviting me here. I'm a researcher and a master student at Northeastern University, wherein I work on industrial IoT and integrate other kind of systems like XR and digital twins talk to each other.
Nice. Awesome. Isaiah, why don't you go next?
Sure. Thank you. Thank you for having me here. It's a pleasure.
Of course.
My name is Isaiah Williams. I'm a junior at UAlbany in New York, studying cybersecurity. I also research in ML dev, mostly computer vision, and I'm a student athlete for our track team. Thank you.
Awesome. Well, thank you for joining us. And last but not least, Brian.
Hello, everyone. Nice to see everyone again. And thank you for having this event. My name is Brian. I'm an engineering senior, focusing in computer science. And I just think anything XR is very cool and it has lots of future potential. So excited to be here.
100%. Totally. Can't agree more. Have you seen, I'm sure you've seen it, Ready Player One? You're familiar?
Oh, yeah.
Oh, yeah. There you go. See, everyone knows it.
Yeah.
Well, thank you so much, guys, for joining us. It's a pleasure to have you here. So we're going to come back to you guys shortly. We'll have our short intro, and then we can dig into the nitty-gritty about your apps. Rajan, why don't you go ahead and share your screen and start the presentation, and we'll get to these demos.
Yep. Awesome. So I think you guys can see the screen, right?
Yep, you're good.
Yeah, good. So I want to start with a quick intro of MIT Reality Hack, right? So I want to give like a very brief intro very quickly on what it actually is. We have been at this event last couple of years. Basically, it's one of the biggest XR hackathon in the world. It's quickly becoming one of the best XR hackathons in the world, where you get participants from all over the world, different professionals, students. You get professionals, you get researchers like Mayank, you get a lot of VCs as well, which are actively looking for new and innovative ideas of where you can like push the boundaries of technology, right? XR being the core focus. But as part of the hackathons, there's also a hardware track. So in the past couple of years, what we have tried to do is we have tried to seed some hardware into the hackathon and see how we can bridge the gap between XR and reality, right? We have seen people do some really cool stuff with hardware, and this year our intent was to give them the RB3 Gen 2 dev kit, which can run a lot of computer vision use cases. We can do a lot of AI on device on RB3 Gen 2. And then the challenge for the hack participants was to kind of broaden that scope, right? Bring IoT, computer vision, smart camera use cases to an XR and see what kind of use cases they can think of, how they can kind of integrate both of these kits together. One of the things we have not had in the past is, hey, how can you actually take a camera feed, do some AI on device, and then actually how does it work with XR, right? How does somebody visualize it? What is the technology stack behind it? How do you actually take the images, show it on an XR screen? So those kind of things, those were the challenges. So there were about 600 participants in total for the overall hackathon, out of which 12 teams participated in the Qualcomm track, right? So 12 teams got the RB3 Gen 2 dev kit. We had 4 engineers from Qualcomm supporting these teams. Total between 12 teams, that were about 60 participants, right? About 5 participants per team. And then to our surprise, usually these hackathons, if there are 10 teams, you get 2 or 3 good projects out of it. This time we were really excited to see 9 teams actually submitting their finished projects, and it was really tough for us to decide the winners, right? And you'll see when you see some of these projects, you'll see why it was so difficult. So
I cannot wait.
Yeah. So I want to kind of quickly brief on what the judging criteria and what the awards were. So initially, when we started, we had 3 awards in mind, right? Best use of AI, which was deploying AI on the edge and using Qualcomm AI Hub, right? People using models from Qualcomm AI Hub, optimizing it for running on the RP3 Gen 2 and deploying it on device. Best in IoT, right? Best who can think of the best use case within an IoT, but integrated with XR, right? That was the second category, and then best social impact, right? What use case has the biggest kind of social impact? That was the third. But we had so many good entries that we couldn't help it, but we had to add one honorable mention, right? We had to give something to one of these teams that completely thought out of the box and did some integrations which even we had not expected, right? So that's we ended up giving four awards instead of 3 awards. So
Nice.
that's overall we have 2 of these teams. You already saw the intro. You saw who they are. Hopefully, in future we'll get the other 2 teams to join the Discord session as well. Unfortunately, today, due to scheduling conflicts, they could not make it. But hopefully, we'll have a future session where we will have those 2 teams as well. But those 2 are
Cool.
best in IoT and best social impact. So I just want to give a quick shout out on what those 2 apps were. Best in IoT, they basically created, you can see the image there, right? So it's an RB3 Gen 2 mounted on like a handle and like a point and shoot sort of a use case where you would point the dev kit to an object and you would press the button and it would do object detection on whatever it is that it is seeing, right? So if you were pointing it at a
That's
sofa,
awesome.
it would detect that it's a sofa. It would crop that image out, and then it would send it to an XR. You could actually visualize it in your space in XR. So you would point
Wow.
it, and then you would see it in an XR headset. That was one. Farsight was they actually built a little like a robot on wheels with RB3 Gen 2, which firefighters would use to send and find people that they need to rescue, right? So they would just send it out. It would do object detection. It would do fire detection, and then it would go out and send the location back to the fire people in an XR headset. Whether it detects
That's
a pet,
awesome.
whether it detects a person, it was they built the they actually 3D printed the whole mounting thing for it, and they actually were running it in within 24 hours. They did the whole end to end. They actually built the hardware. They actually ran the code, and they were actually running around with this kit. So it was pretty awesome to see. Yeah.
And when are those coming to market?
I
I know.
we'll try to get them on Discord first.
Yeah, I know. Well, we have
Yep.
2 of 4, so that's really exciting to be able to talk to AutoChef and Neuroveil. So, but those were really cool too. The point and shoot or point and click
Yeah.
object capture. That's awesome. I mean,
Yeah.
we need things like that to get to everyone's vision of the future. So,
Yeah.
can't wait to hear from AutoChef and Neuroveil.
Yeah. So without further ado, I want to invite AutoChef Mayank and Isaiah to take us away. So just let me know next, and I'll go to the next slide. Mayank.
Uh,
Hey guys,
Sorry, I was muted.
that's okay. No worries.
Morning, good afternoon, wherever you are. We are AutoChef. We are a food freshness detection software, and we utilize IoT, AI, XR, and a few other different technologies and merge it all into one product that we think is just really, really cool, and we're honored to be able to share it with everybody today. So if we could go to the next slide, please, to start off. So Mayank, if you want to start with the team.
Yeah. Hi, everyone. So we were a bunch of passionate engineers having different backgrounds. I'm from IoT, Isaiah's from AI ML, and we have all the people from various experiences, which where we collaborated together to build something which you could use in an everyday as an everyday product, like an everyday solution for a consumer. So we wanted to the kitchen market we thought was very niche and was not covered enough. So
Mhm.
we thought, why not? Let's give it a try and integrate that.
Yeah. Can you talk a little bit more about that before we move on? Like, what did you see that was ripe for innovation in the kitchen market specifically?
So we observed a huge trend in home automation, but that
Hmm.
automation did lack in the kitchen market. I
Yeah.
mean, we eat. I mean, eating food is like we eat 3 times a day, and
Yeah.
it's like we waste a lot of food during that time as well. We forget
Yeah.
sometimes we keep things in the fridge, and after a week or so, we like, oh shit, we could have just utilized that, or even someone else could have utilized that enough. So that's what motivated us to build something like this, and we will discuss more on the
Awesome.
next slide.
Yeah.
Yeah.
So,
Uh,
kind of a broad overview of our project. It's meant to eliminate food waste and help save money. Um, Annually, most houses are losing about like $1,500 worth of food waste, and that's from whether food going bad, not knowing what's in your fridge, not being able to cook certain things because you might not know what to do. So we created a few unique ways that we can kind of combat this. Starting off with kind of like an easy way to just integrate this product into your home. It's
Mhm.
like you just kind of throw it in your fridge, get data coming up on your phone, you get recipes. So we try and make it as easy as possible for our users to just have this product integrated into their daily lives. Anything else from Mike?
Yeah. So another interesting thing was the security and privacy. The user does not want its data to go to the cloud and stream there, right? So we wanted to make use of the edge computing capabilities and integrate everything on the device. So that's one of the things. Yeah, next slide, please. Yeah, to talk more about the functionality perspective, we use the Qualcomm RB3 Gen 2 with QIRP SDK, which had a ROS Humble integrated. And so basically, our we try to stream the messages between the XR headset and the Qualcomm device. We thought it would
Okay.
be interesting wherein you could be anywhere and you could visualize that data. So with that, for that purpose, we use the ROS TCP connector. It's an official Unity plugin, wherein you
Okay.
could use that to serialize and deserialize messages between ROS and XR devices or any other device, for instance. So all the communication was bidirectional. We could stream real time video on the XR device,
Nice.
and also some of the other messages like is it detected. Maybe you could manage everything inside the XR device. So this was an add-on wherein like a proof of concept wherein you could use this technology to expand not just consumer products but also expand it to industrial use cases and other kind of
Yeah.
applications, maybe for training or maybe for predictive maintenance sort of applications.
Yeah. That's awesome. Nice job.
Yeah. And Isaiah, if you'd like to talk more about the vision side of the
Sure.
application.
So outside of being able to have the opportunity of working with the Qualcomm Dev Kit, we also found it really useful. If you go to Qualcomm, I think it's .com/AI Hub, tons and tons of models, great use for developers. And even for the specific chip that we were working with on our dev kit, we were able to find, I think, about 70 to 80 models that we were able to work on. So developing our model for this food freshness detection, I built it on top of a Qualcomm model for object detection. So we would have some easy components to integrate into the device already. And it also saved us a lot of time considering that with this hackathon, we were on maybe a 72-hour time crunch. So without that, it probably would have taken a lot more time, had a lot more issues. So without Qualcomm, it would have been really tough, and they really made it possible with those models that are just open for us to use.
I'm so glad to hear that. Did you guys fine tune it, or did you use the base model that was available?
I used the base model, and then
Okay.
I imported YOLO V8 Nano for training.
Yeah.
And we found a data set on RoboFlow as well. And then we kind of
Nice.
just had to integrate it in.
Okay. Cool.
Also,
Yeah, that sounds about right. The
yeah.
models are really good base models in AI Hub, and then you can do just minimal fine tuning, and usually you get pretty good performance.
Yeah, after working with that, it made a whole world of difference.
Love to hear it. Okay, awesome. You heard it here, guys. Use AI Hub.
Yeah, and definitely the QIRP SDK as well had like great examples which you could run out of the box and just stream some important metrics like the system performance and the camera images. They created all the topics. They had pre-built in topics for that.
Nice. And
Yeah.
how long did it take you guys? Maybe you'll talk about this later. So if
Mhm.
so, feel free to skip over it. But how long did it take you guys to get from like this architecture that you've drawn out to a minimum viable product that you could build on to build out the full app functionality?
Um, So we did that in like 72 hours. So we tried to go through the documentations, and the documentations were really helpful and helped
Okay.
us get started quickly. And then we followed up, and we got a lot of support from the Qualcomm team, and
Oh,
which
good.
resulted in developing all this in like 72 hours or less.
Yeah. Okay. How long to the working? Maybe I wasn't clear. Like from like the idea to something working very minimally, maybe not the full prototype. I'm just curious to know what your experience was like in that
Give or
area.
take, I would say about 2 days, we started to get some traction with something working.
Okay.
Me and my aunt kind of took our best abilities and dispersed a little bit to work faster. So he was solely working on the Qualcomm device and doing the IoT side of things. I was focusing more on the
Okay.
ML, and then once we were both somewhat solidified in what we had, we kind of joined forces. And I think that was really the defining factor in getting our project done in this time frame that we had. And I think without our different skill sets being able to combine, it would have been a lot of a bigger challenge.
Okay. Thank you for sharing that. We did get a question in the audience. So maybe a short answer now, and then we can also bring it as we go through your presentation, because I don't want to derail it too much. But the question was like a 30-second take from each of you guys on your developer experience on the platform. So with this kind of frame that we've been talking about of where you wanted to go to, how you got there, how was it in terms of a development experience compared to other platforms you may have used? Just a quick take is what the question is.
For me, the developer experience was really good. The
Okay.
documentations were really helpful, and there were a lot of FAQs in those which helped us debug any challenges that we came across. I think it was a great experience to work on these tools, and it was quite flexibly. I mean, you could easily get started by running some sample apps which were pre-installed with their SDK. So I think, yeah, it was a great.
Cool. And Isaiah, any input on that same question?
Sure.
Are there any blind spots too?
Blind spots, I would say the more unique your project becomes outside of one of the pre-made Qualcomm models,
Yeah.
the more bumps in the road you might find. For us, it was one major factor that kind of changed everything we had was just how like kind of plug and play style you have it with Qualcomm models. So if you're working on those, you'll have a great time. If you're making your own to operate on this dev kit, I would suggest doing what we did and just following this whole model distillation concept. It'll save you a lot of developing time and also a lot of integration time without having to go back through 100 lines of code.
Yeah, that's a good call out. And I had a hackathon as well recently, and it was a similar experience there. As they, there were teams that tried to do that, and it helped them to do exactly the process you're talking about, which is take a base model, kind of distill it a little bit, and then go from there. But thank you for sharing your insights. I don't want to derail your presentation too much, so go ahead and move forward if you're ready.
Absolutely.
Next slide, please. Yeah. So here are some things that we learned throughout the process, which is primarily integration of XR with IoT and robotics. So we used ROS, and if you're able to integrate ROS with XR technologies and IoT, it's like you could integrate in any of the applications that you could think of. So the another thing was to understand the capabilities and importance of edge computing, which we would not be able to achieve with just using a cloud-based tool. Or it was quite fast because you had on-edge computing, and it was a great opportunity to work with the QIRP SDK, and we also got to learn about a lot of terminologies like the GStreamer plugin. How could you visualize that video feed and all of that? And last but not the least, it was to connect with like-minded people and share knowledge with each other.
Yeah, it's the best part of hackathons like this. You get to meet all these people and share ideas and hopefully collaborate a little, even though you're competing for a prize.
Right.
Yeah. Great to hear.
One awesome thing I would like to add. So working in like computer vision projects specifically with this kind of dev kit, like most laptop cameras, unless you're spending a pretty penny, might not be the greatest. But using a Qualcomm dev kit, it's a great camera. And on top of that, there's a infrared sensor. And that makes a world of difference for the confidence in your model. So we were able to achieve really awesome confidence to the point where we actually trusted the fruits we were getting to eat them after the hackathon. So yeah, definitely apply the vision kit if you can versus just a regular old camera you might have lying around.
So did you double up then? That's what it sounds like? You did the pure vision and then infrared? That's awesome. Yeah, that's smart.
And Mayank was also able to do some really special things with the Qualcomm Vision into Unity that we were talking about earlier.
And I'm sure we'll get to that, so I'm excited to hear more about it.
Yeah.
Next slide, please.
Yeah, here are some of the video photos that we took during our process. So here's me on the right is trying to stream the video from the Qualcomm device. I mean, the goal was to just record just stream the video in real time, and you could see an avatar version of me. It's kind of bluish, wherein I was not able to. I did encode the video, but it was fun playing around with the encoding the RGB and different kind of encoding schemes for the videos on Unity. And here's our team, and we did prototype on on other platforms, and it really helped us get started. We created a storyboard on those platforms, and then started our development, which really helped us during that process.
So yeah, and then also one really fun thing that we were able to do to the far left, one of our team members, Akil, was able to build kind of a live walkthrough of our model, and
That's
getting to
awesome.
see how AutoChef works. And then one of the bonus features we would add would be AR guided recipes to cook through. So it's another really fun addition we get to have.
Yeah. I was wondering what that was, because that's really cool that you guys built the model. So the idea would be to, essentially have some sort of headset that you're looking through, and it's kind of
Right.
overlaying the cook. That
Correct.
would be so cool. Yeah.
In addition, because we could integrate that with the fridge, maybe it could recommend you that this might go bad in a few days, so it could recommend recipes based on that information.
Yeah, and that's such valuable information. And the amateur chefs, amateur home chefs especially, aren't really thinking about those things. They're like, they're so busy with other things, and it's like, oh my gosh, I need to pull the food out. And that's really cool that you guys built that.
Yeah.
Thank you. We had a lot of similar experiences going into it, so it was really fun to collaborate and develop this.
Yeah. Are you guys going to keep working on it?
We're all a bit busy at the moment, since it's kind of nearing finals time for some of us still in university.
Oh, I get it. Yeah.
But we are in talks about continuing this and further developing more.
Yeah, there's a lot of cool stuff there, and it's hosted. So for anyone watching along, that little link at the bottom, I'm sure you've seen it already, but you can go check out the project in more detail there, where we're posting a lot of the development projects that come out of the hackathons and events that we do. So go check it out if you want to learn more. This is really cool, and I can't overstate how much work goes into something like this. So to be able to get through that in 72 hours is really impressive. Good job, guys.
Thank you
so much.
Yeah. And with that, we are on to Neuroveil. This is our second team. So it's going to be Brian. Welcome to the stage.
Hello, good to see you.
So yeah, take it away. Why don't you, I don't know how you plan to start with your slides. Go for it, and then we'll talk about your app.
Sure. So our team Neuroveil made a project related to photobiomodulation. It's this, research phenomena where flashing red light on your eyes at a certain frequency has these positive health benefits, mental, physical, in all of those areas. So, and then
how did you get to this?
Our team lead, he had a pretty deep experience, background in like research and physics, so he kind of knew a lot about the intersection of, biology and physics with like the wavelength frequencies and whatnot. So
yeah, that's really cool. There's a lot of cool research going into that stuff, so I'm glad we get to see some of this today.
Yeah, it's definitely one of our interests at the moment, to see where we can take this project for the next steps.
Cool.
So I guess next. So these are just some of the waves that your brain generates, just like for your own context. And at MIT Reality Hack, we had a lot of really cool sponsors, including Qualcomm and OpenBCI. So OpenBCI, they provided us with brain measuring software.
Amazing.
And then if you go to the next slide, that's kind of what we wanted to see what we could do with the technology if we somehow manipulated those photobiomodulation red lights at frequencies coming from your own brain. And next slide. And this is for the purpose of just becoming a better person. When you have photobiomodulation, the red light will heal your cells, and then awakens the mitochondria. The mitochondria are the powerhouse of the cell, and then all of this energy allows you to just be more healthier, and we also wanted to add a synchronization element to it since we had access to a lot of different hardware given the scale of MIT Reality Hack.
Yeah.
And the next slide. And we wanted to demonstrate the synchronization with the cymatic resonator. This
Yeah.
is basically like a bowl of water on a speaker, but if you vibrate the speaker at certain frequencies, you'll have these really cool patterns, as you see here, show up on the water.
Mm-hmm. There's a lot of cool
And-
math behind that too for any mathematicians in the group. If you go and look at the way that these cymatics overlap with each other and then look at the frequencies, it's like that's a whole PhD project of its own.
There's definitely this is the pattern that we got from our project. So this is what we came up with. We have those two electrode caps you see on our two users. So they wear those and it measures the gamma, the beta brain waves.
Yeah.
And then that gets transmitted to those glasses that they have on. It has a ring of red light around each eye to induce that photobiomodulation effect. And then in the middle is the speaker with the bowl of water on the top. And then that is the cymatic resonator portion that shows the synchronization. And this is the hardware that we used. We have the OpenBCI Cyton, which collects data, and the electrode cap, which measures the brainwaves. And with all of this data, there's 8 channels that run at 250 hertz. So even from 5 minutes of recording data, there's a lot of it that we have to analyze if we want to do any kind of inference on it. And then that's where the Qualcomm RB3 Gen 2 came in. It's a very powerful piece of hardware that let us train and run our own models with the data that we got from performing photobiomodulation. So if you go to the next slide, you'll see what kind of data we were getting. So there's 8 channels, and every second, 250 samples of data are collected. So just to reiterate, this just a large amount of data that we need to process. And the next slide shows what that data represents. So we had the electrode cap, and then these 8 circled nodes are where from the brain that we measured.
Okay.
We had more frontal lobe nodes because we learned that part of the brain is more associated with your decision making and thus your personality and just your morals, those kinds of, that part of your thinking. And that's what we wanted to capture with the data. And then this was all fed into the system, which is on the next slide. So we have the 2 Cytons here. That is the OpenBCI data receiver. So we collect 2 streams of data from the 2 users wearing the glasses in that picture. This gets sent to a web server, which does some fast Fourier transform. It's like an analysis to get a frequency out of the brain data, which is then sent to the photobiomodulation glasses to flash at that new frequency that was calculated from the fast Fourier transform and the raw brain data. This data is also sent to the cymatic speaker to show that resonance pattern if they do manage to synchronize at the same frequency. And this data is also sent to the AI model on the Qualcomm RB3 for inference output. And then if you go to the next slide, so the data that we decided to train on for the AI model was the measured brainwaves of each of our team members. We had 5 team members, so each person worked for about 5 to 6 minutes. And then that came out to around 30 minutes of data. And that was, I think, 500,000 almost lines, rows of data that we had to process.
Nice.
But we managed to train a custom transformer model on the RB3 Gen 2, which was able to take in that data. And if you fed it new user data, it would be able to infer whose personality on the team you're most similar to. So it's a little extra analysis on top of the synchronization and photobiomodulation.
while we have this picture up, could you talk maybe a little bit more about how the synchronization works and what they're trying to accomplish just with this frame of reference in it? Because like I'm following along with you, but I've looked into this. So maybe for people who are less familiar with what you're trying to synchronize and how the water plays into that and all that, the cymatics.
Sure. So each person, so this is a 2-person demonstration. Each person is wearing a cap that measures your brainwaves, and we made a system that collects that brainwave data, and then detects the highest or strongest frequency in it, which is then sent back to the glasses that the people are wearing. And then these glasses have red LED lights on the inside that flash at that frequency that we got from the brain data. So the photobiomodulation is affected by, your brain state and what kind of data the brain measuring hardware is detecting at that time. So whatever you're thinking of.
Yeah. So how does it align then? What's the purpose of aligning the photobiomodulation with the brain waves? What are you trying to align together to?
Yeah, so once these two people have connected their glasses and their electrode caps together, they swap. So the light that you're seeing flash is from the other person.
Okay.
Yeah,
and you're trying to align it then?
Yeah, and then if you're able to kind of reach the same brain state of like calmness or zen, that those frequencies, but this whole time those frequencies are being sent to the cymatics resonator, and if those frequencies align, then that pattern will show up as it does here.
Nice. Okay, that's awesome. Thank you for sharing.
Just a way to, visualize, brain synchronization. Maybe went a little overboard. It looks cool.
Overboard? You're underboard.
Yeah.
There's so much more you could do here.
Yeah.
Well, just like this slide is capturing. Yeah.
So, yep, that's our project. And we're really thankful for MIT Reality Hack and the sponsors that showed up to let us try their new technology for free. It's a very fun experience for all of us.
Good. And are you going to continue the work from where you are now? What are your plans to keep digging into the field?
I think one of us is working on some kind of like blockchain technology, and then another person is doing like VR research with eye tracking. So maybe there's a way to combine all of that together.
Awesome. Yeah, there's a lot that you can do there. There's a lot that you can do in the space. So with that,
one of the questions I had from my end was, can you talk a little bit more about kind of similar question to what AutoChef had, like your experience with RB3 Gen 2?
Yeah.
I know you trained your own transformer model and doing inferencing on device. You had challenges there. So can you elaborate more on what you ended up doing in RB3 Gen 2? I think it would be great because a lot of times these hackathons are a good opportunity even for Qualcomm to learn new things. So I think what your experience was with the platform, I think that was unique as well. So why don't you talk a little bit about that?
Sure. So we did some initial research, maybe about 2-3 hours, just on the hardware, how to connect to it. Qualcomm had great documentation on how to connect to the hardware, either via PuTTY or some other SSH or SCP client. And once we kind of got the basics down, we realized that the chip uses OPKG, like package manager, which then forced us to pivot and try to find a way to get not necessarily the video and image AI models available on AI Hub, but since we're working with brain data, we needed a different type of model. So that forced us to make a Docker container of that of our model, which then allowed us to install TensorFlow and PyTorch and the other necessary libraries that wasn't already included in OPKG. The Docker let us kind of circumvent that and then build out the application as we needed. So
love to hear that.
Yeah,
working.
every now and then you come across use case that's completely out of the box, right? So we were
Yes.
focusing on computer vision use cases. We were focusing on the IM SDK, QIRP, a lot of those tools. But then this team did not want to do any of those use cases, right? Their use case was not computer vision based. That was completely different data type, and they figured out a way to get that inferencing to work on device, right? It's within a Docker container. A lot of those things were kind of not very well documented. I would say it out there.
Yeah.
But Brian and team, you guys did a great job at figuring those things out, figuring out that hey, you can run this in a Docker container, you can get all the dependencies that you want, and still go ahead and execute the project. I think that was kudos. I think that was one of the reasons you guys got best of AI, because
Thank
it
you.
was out of the box and you guys figured out a way to make it work on the dev kit. It was not optimized, probably not using NPU, but still
Yeah.
it was a use case. It was thinking out of the box that got you guys.
Yeah.
Got you guys there.
Yeah, that was another thing. Use the NPU. The future work is just none of us have an RB3 right now, so
Yeah.
keep working on it.
This is really cool. I can't believe you guys. How long did it take you guys to build this? Was same 72-hour period?
Yeah, but I think what helped was we each stuck to our, I guess, workload. Like for example, we had an
Yeah.
artist on our team, and she spent the entire time editing a 1-minute video. I think it came out very good. And it's like similarly, we didn't have, each of our workloads wasn't that much,
Mhm.
but we just since we all stayed focused on our own goals over the course of dozens of hours, I think we were
Yeah.
able to put it together.
You know what they say, teamwork makes the dream work. And
Yeah,
I wholeheartedly believe it. And this is proof too.
Yeah. Yes.
Yeah. So since we're at the end now, why don't we bring back the other participants just for a little bit? We'll have a short Q&A here with everyone involved. And that way we can, if there's any questions from the audience, we have a chance to answer them. Oh, sorry, Isaiah, looks like your camera's not connected. We'll add you back in a second once it's connected. But any questions from the audience that you want them to answer beyond just the development experience? Oh, good, Isaiah, nice. And let me add that. Let's see, there's things. Looks like some questions are coming in. It just takes some time. Anything you guys want to talk about here with each other, or anything you learned from each other's projects, or what you have, cool things you have coming up in the future, personal projects?
Definitely, I can talk about. Currently, I am using the same principles, same architecture, and implementing in one of my other projects, wherein I'm trying to integrate a robotic arm and operate that remotely via a XR headset. And for this purpose, we were able to test it
Awesome.
and present it from California. We were at a conference, and we were able to operate the. Due to logistics, we could not take the actual robotic arm, and we were able to stream the video and as well as operate or control the robotic arm wirelessly from California and at Boston.
That's awesome. That is incredible.
Yeah.
Oh, Isaiah, I think your mic is muted. Oh, maybe you're muted inside of our chat.
Can you hear me now?
Yeah, you're good. Go for
I
it.
have like hardware switches and digital.
It's okay, no worries.
I'm the chair of an undergrad chapter of a science organization on campus, and we're
Nice.
actually hosting an MIT panel in mid-April-ish to kind of talk about a few different projects that are highlighted. And one former hackathon contestant from last year is now doing a master's dissertation about her project, which is a little similar to ours. It's about like food detection softwares. So it's really cool to see how these things kind of progress and develop.
Right. And once you've gone through the experience too, really interesting to see, you know, that a lot of times the barriers are mental. You know, you can put together some of these cool products. You know, everyone in the comments was like, wow, that's awesome, you know, and you can make a product out of it in these days with AI and all the tools we have available really easily. And the sky's the limit once you have your MVP. Then you just continue working on it and cool things will always come out. So it's really cool to see what you guys were able to do. I hope you continue to work on these, maybe not these projects, but if not these, then other cool things, because those are some really great ideas you guys all came up with.
Yeah, it's so awesome to see all of these great ideas, but also you guys solving difficult challenges, right? I think a lot of
Yeah,
times we go to hackathons, especially at MIT, right? You are at MIT, you should look to solve difficult challenges, right? You shouldn't look to take the easy way out, right?
Yeah.
So
yeah,
we see that in some spaces where a lot of hackers throw their hands up in the air and say, "Hey, it's too difficult for me to do," right? But it's the challenge of it, right? That's the whole point of being at events like these, collaborating with like-minded engineers, figuring things out, accepting the challenge and solving difficult problems, right? I think that's
yeah,
where all of you, all 9 teams, I would say, excel, but especially the four recognized here, right? So it's really the energy at hackathons is definitely something else, and you guys bring that energy. So we love doing these events, right? We love collaborating with you guys, being there, supporting you guys. So it's really a great experience for us too.
yeah. Couldn't have said it better myself. Thanks, Rajan. Do you guys have any last closing thoughts? I mean, we're nearing the end here. We had, let me check. Yeah, no, there's no questions from the audience. Any last thoughts you guys want to share? Any, you know, insights or anything else? Now's your chance.
Is there any way to maybe try the RB3 again? Like, I just had this idea with, I think it'd be work really well for like insurance frauds where like cars try to brake in front of drivers and then get hit on purpose. I think maybe RB3 would be a really good like dashboard cam. Just interested in building that out.
Yeah,
Interesting.
we can connect with you offline, Brian, and see what.
Okay.
Yeah, that's what I was gonna say.
Yeah.
We have your info, so we'll be in touch, and we'll definitely see what we can do to help you out. We did get one other question from the audience, and I know you guys already answered, but Fixer's such a huge piece of our audience, so I want to make sure we get to his question as well. And he was asking about what kind of projects you have coming up. I know you guys mostly said that you're busy and you don't really have plans to continue pursuing your projects. But if you could quickly recap on, you know, what you guys are looking to in the near future, and also maybe just pie in the sky what you'd like to accomplish in your careers from a technical project perspective.
So definitely, I would love to keep expanding on this knowledge and integrate a lot of other use cases, maybe for industrial IoT or even medical-based solutions. Because
Yeah,
also in medical as well, there's a lot of concerns about security and privacy. You don't want the data to go outside. So that's something wherein we could use Qualcomm devices or such powerful capabilities and implement on-chip AI.
yeah. Have any of you guys tried the X Elite by any chance?
Um,
The
mm,
laptop? Okay. That's for another day, but it's, you know, there's a lot of capability there too in terms of edge AI power. So, but more in a laptop form factor. But yeah, Isaiah, Brian, you guys want to recap any of
So
the projects?
kind of coming towards like the time to make a decision on what I want to do, whether it's like
Yeah.
immediately start working post grad, further education. I'm debating nanoscale, since we do have nanoscale engineering complexes within our college, and some really cool new research. So possibly developing topological chips as a master's side of work, basically.
That's awesome. Yeah, nanoscale's another one that's, you know, the smaller we can look into the quantum realm, the more the nanoscale becomes approachable, right?
Yeah.
Yeah. Brian, any
Yeah.
cool projects?
Just yeah, like I do have an AI project just finishing up school that I wanted to try and flesh out. The problem was like this: I didn't have enough compute on my laptop. But
Yeah.
I'm also interested in like on-device computing as well. Seems to be a lot of the popular theme at hackathons and stuff. And
Yeah.
I just like hackathons, just having a like trying to build like robust things in a short amount of time. It's a fun challenge. So just been doing those as well.
Nice. Yeah, I mean, to your point about Edge AI, that's kind of my area of, I don't know if I want to say expertise, but maybe interest and passion. It's really cool to see what you can do with computers. And I think, 10 years ago, when I first was starting out to explore the space, you didn't have a lot of power available. But now with all of the different ARM chips, you have not only a lot of power, but a lot of battery life to go with it. And, we did a hackathon with the X Elites, and you have an NPU, a GPU, and a CPU, and you can split your work across those the three components of the SoC, and you can really do a lot more. And that's today. And if you start thinking 5-10 years in the future, and you're building today for what's to come, the sky's the limit. We're going to probably see computers in the next 20 years that are, the desktop class servers of yesterday that are in a laptop, or smaller, and they're portable. And so what can you do that empowers people to use their own data that maybe they wouldn't want to put on the cloud,
Yeah.
So it's great space. Keep exploring. And like we said, reach out to us if you want any additional resources or insights, and if we can help in any way, because it's projects like all of yours that we want to keep supporting and growing and see what becomes of them.
Sure, thank you. I'm already part of the Slack too, so.
Amazing. Yeah, AI Hub, awesome. Which, quick shout out, if you're not part of it, if you are using AI Hub, they have a Slack channel that's in addition to our Discord channel, where you can talk directly with the team, and they support all their models and all their sample outs and everything. And the whole entire team is on that Slack chat. So check them out. Well, with that, unfortunately, our time has come to an end. It was really great to have all of you on the stream with us, sharing your projects. I really wish we had more time to talk about them and dig into them, and hands-on demos and all that fun stuff. But the day will come where we'll be able to do that. But huge thank you to you guys for joining us. Huge kudos for everything that you guys built in the hackathon. It's super impressive to see what you guys were able to do, and don't stop, keep pushing. Rajan, Ramya, any closing thoughts?
I was just going to say the projects that came out of the MIT, they really inspire me to get started on doing something with the RB3 Gen 2. I've been having the kit for a while, but it's mostly the readiness evaluation and stuff that we do here at Qualcomm. But building a project right from scratch and putting it out there as a use case project is really something that's great. So yeah, maybe I'll find some time to do it for myself.
Yeah,
like I said before, these events, when you go to these events, when you talk to the participants and you see their passion in that they put in their projects, it's like a recharge session for us. We usually I do these events because they are fun to do, but they inspire, and it's like a recharge session. Every 6 months you go, you get recharged, and you bring that passion back to the work that you do. So that's awesome.
Yeah. Well, that's it then. Looks like we're at the end. Thanks again for another successful session to everyone in the audience. We'll do these, as always. We continue to do more and more of these in a bunch of different areas. So if you have any suggestions, please don't hesitate to drop them in the chat, add us in the Discord, and we'll continue to bring these fun sessions with more people like our developers today. And I can't wait to see you guys in the next one. It's always a pleasure to do these. So thanks again to everyone who joined today. Thanks, Rajan. Thanks, Ramya, for stewarding them through the hackathon process. And we'll see you all next time.
Thank you.
Thank you.
Yep. Thanks, guys.